All right, so let's talk about ordered pairs and graphs. All right, so first, what you're going to want to know is how to plot a point. So each point has an x and a y value, okay? So if you look over here, what does it mean? So this right here, so x and y is a point, is a coordinate point, and here you see a graph, which is the coordinate system. In the coordinate system, there is left and right and up and down. So left and right is your x-axis, and up and down is your y-axis, okay? So, and where they meet is called the origin. And that is 0, 0, okay? So that's where the origin is where the two axes meet. And every time you plot a point, you always want to start at the origin. Which again has a coordinate point of 0, 0, okay? So when you start at 0, 0, you will go left or right, and it all depends on what that x value is. So if it's a negative, you would go left. If it's a positive, you will go right. And then the y value, if it's a negative, you go down. If it's a positive, then you go up. So you move your x first, and then your y, and then you'll have your point. So let's take a few examples here. Let's plot point A, and we'll call that point A 8, 4. Okay? So again, if you notice that my x value is positive 8, my y value is, excuse me, is positive 4. So I will come over here, start at the origin, move 8 times to the right, 6, 7, 8. And then I'll move 4 times up. 1, 2, 3, 4. So that is my point right there. Okay. So with that being said, so this is my A. This is my A, which has a point 8, 4. All right. So let's plot another point. Let's do light blue. Let's point B. In point B, I'm going to have negative 9, 2. So my x value is negative 9. My y value is 2. So I start at the origin. I'm going to go my x value, negative 9. So I go left, 1, 2, 3, 4, 5, 6, 7, 8, 9. And I go up to 1, 2. So there's that point. And this point here is my B, and it has a point negative 9, 2. Okay? All right, so let's plot another point. Let's call it C, and C is going to be negative 8, negative 3. So my x value is negative 8, my y value is negative 3. So 1, 2, 3, 4, 5, 6, 7, 8, and then down 3. 1, 2, 3. And you might ask me, hey, how do you know if I go left or right, up or down? And it all depends on the value of the x and the y. Since the x is negative 8, when I start at the origin, means I go left for negative. And then when I get to that point, I move my y value, which is negative 3, so I go down 3, and down means negative. Okay? So there goes that, and this is my point C, and that point is negative 8, negative 3. There we go. And let's do one more. Let's do D, and we'll call D 9, negative 4. So let's try that again. So 9 is my x value, positive 9. So that means I move right. And negative 4 is my y value, so that means I go down. So 1, 2, 3, 4, 5, 6, 7, 8, and 9, and then down 4. 1, 2, 3, 4. There that is. And this is my point D. And that is 9, -4. Okay? So notice how I move those. Now, the other thing that they're going to want you to know is if you notice that the X and Y axis cuts this coordinate system into 4 different pieces. Okay? The top right-hand corner. You got the top right-hand corner, the top left-hand corner, the bottom left-hand corner, and the bottom right-hand corner. Okay? Now, we call these quadrants. And it always starts on the top right, and this is called the quadrant 1. And we also could just label this as Roman numeral 1. And then over here, we have quadrant 2, which we can use Roman numeral 2. And then over here, bottom left, we have quadrant 3, or Roman numeral 3. And then over here on the right, we have quadrant 4. I kind of don't like when I do that, so I'm going to stop that. Or Roman numeral 4. There we go. All right. So notice how my first. So how about if I put it this way? So notice that my A, okay, is in quadrant 1. And notice that in quadrant 1, I have to move right and then up. So right means positive X, up means positive Y. So in quadrant 1, every point in quadrant 1 is going to be a positive X and a positive Y. Everything in quadrant 2, right? Quadrant 2, to get there, I got to move left and up. So left means a negative X and a positive Y. Quadrant 3, I got to move left and down. So left, negative X, down, negative Y. In quadrant 4, I got to move right and down. So right means positive X and down means negative Y. Okay? So depending on where your points are, if you plot it, you'll know which quadrants they are in, so that will help you there. Okay? The other thing that they want to talk about is also the Y-intercept. The Y-intercept, I'm going to short this to Y-int. Okay, so if you see Y-int, you know that I'm talking about the Y-intercept. So, actually, I'm going to move this down below it. There we go, so you know there. So let's say, for example, I decide to, let me see, I used almost everything. So let's just do this. Let's say I plot a point right here, okay? So this is called a Y-intercept. Why is it called a Y-intercept? Because it's where it crosses the Y-axis. Okay, I know, very creative name. Y-intercept, where it crosses the Y-axis. All right, so what we're gonna do is, if you notice this, if we were to name this point, right? If we were to name this point, we start at the origin, we move left and right, none. So my x value will be 0. And then I move down 6. So 0, negative 6 would be my so-called y-intercept. Let's plot another one. Let's plot this one right here. All right, so if we were looking at this point here, what would that be? So we, again, start the origin, left and right none, and down 8. So left and right none, and down 8, so negative 8. All right, so that's another y-intercept. Anything on that y-axis can be considered a y-intercept. But what I wanted to point out to you is, what do you notice about these two y-intercepts in terms of the point? That's right. You notice that the x value is 0. Okay? So that means that anytime you have a y-intercept, it's always 0 comma some y value. Right? So remember that. That's important. In the y-intercept, the x value is always equal to 0. Okay? All right. So what other things do they want you to know here? They also want you to know, they're going to ask you questions like, is it a solution? So a couple of things can happen in terms of when they're asking you if it's a solution or not. All right. One is they could give you a point and the equation of a line, and you have to figure that out. So, for example, is 2, 4 a solution of y equals 4x minus 1? Okay, so how do I go about doing that? So what I want to do is I want to look at my x value. Let's make it red. And what I'm going to do is I'm going to replace that with the x value here. And then same thing with the y value. So I want to replace that y value with that, and this y value with that as well. Okay? So that's what I'm going to do. So here we go. So we're going to say y equals, so we're going to say 4 equals 2, 4 times 2 minus 1. Okay? So we're going to work on the left side, we're going to work on the right side and see what it equals to. So 4 is equal to 8 minus 1, and 4 is 4 equal to 7. And the answer is no. So therefore, you know that 2, 4 is not a solution. Okay, there we go. So let's do another one. So example is negative 4, negative 17 a solution of y equals 4x minus 1. So let's plug it in. Let's see. So we would say negative 17, is that equal to 4 times negative 4 minus 1? So is negative 17 equal to negative 16 minus 1? Negative 17, is that equal to negative 17? Yes. So negative 4, negative 17 is a solution. Okay? What else could happen? Well, if you notice, before I continue on, if you notice what's important here, what kind of concepts are important in here? Yes, you have to plug in the x in for the x, the y in for the y. That is important. But better yet, what's even more important in terms of conceptually speaking is the order of operations. Okay? And what is the order of operations? Remember, first, you have to do your parentheses. Second, you have to do your exponents. Third, you have to multiply or divide from left to right. Fourth, you have to add or subtract from left to right. Okay? So, again, the concept is the order operations. You can plug the number in, that's great, but essentially the concept here is about the order operations. All right? So what's the second way? The second way, they could give you a line. That looks like a good line right there. Okay? So they can still ask you, hey, actually, you know what? Let's do this. Shorten this up a little bit, make it blue still. All right, so they can still ask you, is 2, 4 a solution of this graph? So the first thing was, give me a point and an equation. So a point and an equation and see if that's a solution. Second way is that they can give you a graph and ask you if a point is a solution. This is easier. Why? Because, let me do this here. Let's make this point red. Okay? So if you were to plot 2, 4, so you go in, you plot 2, 4, 2 is positive, so I move right. 4 is positive, and that's a y value, so I move up. So here's my 2, 4. And basically this question is asking, is this point on that blue line, on that graph line? And the answer is no. 2, 4 is not a solution. Okay? Actually, let's do it this way. This might be easier. Make it look neater. There we go. All right? So 2, 4 is not a solution. What if it said, is -6, -3 a solution of this graph? So let's make -6, -3, a different color. Let's go with orange. Okay? So let's plot -6, -3. -6 is an x value, so I go left. -3 is a y value, so I go down. So left 6, down 3, boom. So yes, -6, -3 is a solution. Okay? There we go. That looks better. All right. Okay. So that's another way that they can show you. All right. Now, the other part that they want you to know is about equations of a line. And I want to teach you specifically one of them, which is called slope intercept form. Okay? So what's the slope intercept form? It's the y is equal to mx plus b. All right? So y equals mx plus b. So with that being said, what does this mean? it means that if I can get y, if I get y all by itself on one side, then I will know what the slope is and what the y-intercept is. Okay? So let's see. Let's take a look. So let's talk about the y-intercept here. All right. So this is called the y-intercept. And that point is 0, comma, b. So if this was plus b, that means it's positive b, 0, comma, positive b. If this was minus b, then it would be 0, comma, negative b. Okay? So that would be my y-intercept. And then the number that is in the number or fraction that's in front of x is called my slope. And mainly this is rise over run. Okay? So remember, if my m, my slope, was just a single number like 8, I can actually make 8 a fraction, right? I just put it over 1. 8 over 1 would be a fraction, but it still equals to 8. All right? So rise over run. So if my rise, the top of the fraction or the numerator, is positive, then I would move up. If it's negative, I would move down. Run is running left and right, and that's the bottom or denominator. If it was positive, I would move right. If it was negative, I would move left. Okay? Try to make these arrows look nice, but I'm only that good. All right, so how do I want to do this? So if someone was to call you and say, hey, I'm lost, can you give me some directions? What's the first question you would ask them? Where are you at? Right? So you need to know where to start in order to give them directions of how to move or how to drive, right? So if you think about this right here, when I use this to graph, I want to know where to start. So you're going to start at the y-intercept, plotting the y-intercept. Okay? Okay, cool. You're here at this y-intercept. And if you look at the slope, slope has m. If you think of m as how you move from that y-intercept, then you can get to the next point. Okay? So let's try this. So let's say I do, let's do a orange as my first example. So let's say this first example says y is equal to x. You're like, that looks weird, right? In fact, I'm going to do it this way. Okay? You're like, well, that looks kind of weird because what I know is, y equals mx plus b. And I go, wait a minute, y equals x. I don't see an m and I don't see a b. Well, the m is actually there, right? Because in front of this x, there's always a 1, right? So my slope is equal to 1, but I can make that a fraction by putting it over 1. No problem. But how about this part right here? I don't have a b. Well, typically, we wouldn't write that b, right? So essentially, this is a plus 0. So if there's no b in existence, it's going to be plus 0, right? You don't, like when you make your shopping list and you look on your kitchen counter, you're like, well, we have enough bananas, honey. We don't need any. Do they put down 0 bananas on their shopping list? No, they just don't put it on there. All right, same idea. All right, so this is telling me my y-intercept is 0, 0. Okay, and this 0 here is from that. Okay, so the first 0 is that what I know about y-intercepts. The x value is always 0. But the second 0 is coming from the original equation. So again, I would start with my y-intercept. So y-intercept is where I'm going to plot. Then I'm going to use my slope to move. My slope, what does it say? It's telling me it's 1, 1. In fact, this is what I'm going to do. I'm going to bring this and put it down here. There's a reason for it. And here's the reason why. The reason is because since there's a positive 1 on top, that means I'm going to move up 1. And the bottom 1 is a positive, so I'm going to move right 1. So from here, I go move up 1, right 1, and there it is. Okay? So let me get rid of those. Ooh. Up 1, right 1. So there's my 2 points. Now, if you want to, you can keep on going. If you want to, you can keep on moving up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. Okay, you could do that if you want to, but you only need 2 points to draw a line. If anything, when you do more, it just helps the picture look better and more accurate. Okay, so there is my line, y equals x. Okay. So let's do one that is not so, not using the origin as my y-intercept. What if it's different, right? Okay, so let's do another example. Let's say this example here. Let's say that this says 2y is plus 3x equals to negative 2. Okay, so my goal here is to get y by itself because, again, if I get y by itself, I can find the slope and the y-intercept, right? All right, so let's get y by itself. All right, so what do I have to do to get y by itself? I got to subtract 3x. I get 2y is equal to negative 3x minus 2, because those are not like terms, so I can't add them together. So there it is. I wrote the x first, why? Because if you look at my equation here, equation of a line, I have the x first and then plus b. Okay, so the y is still not by itself, so I'm going to have to divide it by 2. So that means my equation is y is equal to negative 3 halves x minus 1. So if I can divide the two numbers like negative 2 and 2 and get negative 1, great. However, negative 3 divided by 2 is like negative 1.5. I don't want negative 1.5. I want to keep it as a fraction. So negative 3 halves, I'm just going to keep. So what does this say? It says that my y-intercept is 0, negative 1, and my slope is negative 3, 2. Well, what does that tell me? Well, the top is rise, the bottom is run. So rise, negative 3, that means I'm going to go down 3. And the bottom is positive 2, so I go right 2. So first, I got to plot my y-intercept. My y-intercept is 0, negative 1. So 0, negative 1 is right here. Then I'm going to go down 3, right 2. Okay? So 1, 2, 3, right 2. 1, 2, 3, right 2. Okay? So down 3, right 2. Down 3, right 2. Okay? So now I can connect those points. Let's see how well I can do that. And there we go. Okay? So now this equation right here is y is equal to negative 3 halves x minus 1. Okay? All right. So the other thing I want to bring up to you is this. Take a look at this. And I'm going to go over it again at some point. So if you notice that the slope here is a positive 1, while the slope here is a negative 3 over 2. Okay? So let's look at the positive 1. So it's an orange line. And when you go from left to right, notice what the orange line did. It went upward. Okay? So when I go left to right and my graph is going up, that means my slope has to be positive. Okay? Over here, I have a negative slope. So going from left to right, if you look at the blue line, going from left to right, what happens? My graph is going downward. All right? So when it's going from left to right and my line goes downward, then my slope must be negative. Okay? So we got to kind of think about those two things as well so that we know, hey, I'm graphing the right thing. Okay? So again, so in order to use this equation of a line, I want to get y by itself first, so I can find my y-intercept and my slope. And once I find those two, I'm going to plot my y-intercept, and then I'm going to use my slope to move to my next point from that y-intercept. So when someone asks you, hey, I'm lost, give me directions, your first question is, where are you at? So when they tell you where you're at, y-intercept, then you can say, okay, so from that spot, drive here. You're not going to tell them, hey, go back to the origin and then move, right? You're going to say, okay, so you're at the corner where McDonald's is. Great. Here's where you go, right? You're going to start at that y-intercept, okay? So hopefully that helps you guys. If you have any questions, let me know.